Our next topic is divisibility. Let's start with a formal definition of divisibility. If a and b are integers, then b divides a if there is an integer c such that a equals b times c. Now that seems a little difficult to understand when we look at it so abstractly. So let's look at this using some more concrete examples with numbers. There's a little bit of notation we're going to have to get used to here. If we read this statement, it says, does 3 divide 12? That vertical line you see between the 3 and the 12 is the word divide. You may find that it's easier to think about this if you add one more word to that. So instead of saying, does 3 divide 12, it might be easier for you to think of it as, does 3 divide into 12? Well, the answer is yes, 3 does divide 12. 3 does divide into 12. And according to this definition, 3 divides 12 because there is a number, and that number is 4, that we can multiply the 3 times so that we end up with a product of 12. So 3 divides 12 because 12 equals 3 times an integer 4. Let's look at this in a little more concrete way and relate it to something we've already talked about. We've discussed division as representing an idea of grouping objects. So if we want to know whether 3 divides 12, we can think of ways to take 12 objects and form them into 3 equal groups. So if we take these 12 objects and we put an equal number of objects in each group, we find that there are 4 objects in each group. So we know that 3 divides 12 because we can take the 12 objects, we can divide them into 3 equal groups, and we can have 4 in each of those equal groups. Does 3 divide 7? Well, let's look at the set model to think about what's happening when we try to divide 7 objects into 3 equal groups. Since we have to have an equal number of objects in each group, we can put 2 objects in each group, but we do have 1 left over, and we know that that 1 left over is called a remainder. So to answer the question, does 3 divide 7, we would say no, and the reason is that there is no integer that we can multiply 3 times to get the number 7. Now that doesn't mean there isn't a number we can multiply 3 times to get 7. There is, but that number is not an integer. Does 6 divide 12? Well, the answer is yes, because 12 can be rewritten as 6 times the integer 2. And this one's a little tricky. Does 24 divide 12? So what that's saying is, can we take 12 objects and break them up into 24 equal groups and have a whole number of objects in each group? And the answer is no, we can't do that. It's because there is no integer that we can multiply 24 times to get the number 12. Is there a number we can multiply 24 times to get 12? Absolutely, but that number is the number 1/2, and 1/2 is not an integer. So there's some tests that we have for divisibility, tests that we can perform on whole numbers to decide whether or not they can be divided by other whole numbers. Some of these are going to be familiar to you and some of them might not be familiar to you, but let's just list them for now, and then we will use these divisibility tests to test numbers for divisibility. A number is divisible by 2 if it's an even number. So numbers that end in 0, 2, 4, 6, or 8 can be divided by the number 2. A number is divisible by 3 if the sum of the digits in that number are divisible by 3. A number is divisible by 4 if the number formed by the last two digits is divisible by 4. A number is divisible by 5 if that number ends in either a 0 or a 5. A number is divisible by 6 if it is divisible by both 2 and 3. Now the divisibility rule for 7 will probably not make much sense until we actually do it, but we're going to say cross out, double, subtract until you can determine whether or not you have a number divisible by 7. The rule for 8 is if the number formed by the last 3 digits of the number is divisible by 8, so is the original number. A number is divisible by 9 if the sum of all of its digits is divisible by 9. A number is divisible by 10 if it ends in a 0. And finally, a number is divisible by 11 if the difference of its alternate digits sum is divisible by 11. This one's going to make more sense when we actually do it, and we're going to think of it as the ocean waves rule. So let's test a number for divisibility by 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And we'll start with the number 5,182. So first of all, is this number divisible by 2? And the answer is yes, because it's an even number. Now when we're testing numbers for divisibility, we're not dividing by the number we're testing for. In other words, we are not actually dividing 5,182 by 2. When we're asked to test for divisibility, we are asked to determine if the number is divisible by another number by using these rules, not by actually dividing by that number. So is 5,182 divisible by 3? It is not. And the test for 3 is to add all the digits of the number together. So we add 5 plus 1 plus 8 plus 2, and we get 16. And 3 does not divide into 16, so it is not divisible by 3. How about 4? Well, the rule for 4 is you look at the number formed by just the last 2 digits of the number. So we're going to look at the 8 and the 2 as an 82, and since we can't divide 4 into 82 without getting a remainder, we can't divide 5,182 by 4 either. The rule for 5 is to look at the last digit of the number. It's not a 0 or a 5, so 5,182 cannot be divided by 5. The rule for 6 is if the number is divisible by both 2 and 3, then it is divisible by 6. And since it's not divisible by 3, it's not divisible by 6. So the rule for 7, we said, was cross out, double, subtract. So here's how that works. We're going to cross out the last digit in 5,182. We'll take that crossed out digit, that 2, and double it. That gives us a 4. And we'll subtract it from the remaining number. So 518 minus 4 is 514. Now I'm going to look at 514 and try to figure out whether that can be divided by 7. I'm not really sure. It's pretty big. So let's repeat the process. cross out the 4, double it to get an 8, and subtract 8 from 51. That leaves us with 43. So now we think, does 43 divide by 7 evenly? Can we divide 43 by 7 and not get a remainder? And the answer is no. We're going to get a remainder. I know that 6 times 7 is 42. 43, if I tried to divide it by 7, would be 6 with a remainder of 1. So I can conclude from that that 7 does not divide into 5,182, and the reason I'm going to give is that 7 will not divide into 43. Now the supporting work for that argument that 7 does not divide into 43 is over on the right with my process of cross out, double, subtract. The rule for 8 is if the last 3 digits of a number form a number that is divisible by 8, then so is the original number. So I want to know, can I divide 8 into 182 and not get a remainder? The answer is no. If I try to divide 182 by 8, I will get a remainder. The rule for 9 is add the digits of the number together. 5 plus 1 plus 8 plus 2. We've already done that. We did that with the rule for 3. And see if we can divide that number by 9. And we can't. We cannot divide 9 into 16 without getting a remainder. So 5,182 is not divisible by 9. The rule for 10 is to look at the last digit of the number. It must be a 0. It is not. So we cannot divide 5,182 by 10. And the rule for 11, we called it the ocean waves rule. So here's how that works. Take your number and add alternate digits together. So if we add the 5 and the 8, that's every other digit. 5 plus 8 is 13. And then add every other digit, in this case starting with the 1. 1 plus 2 is 3, and then subtract those two numbers that we got. So 13 minus 3 is 10. And then ask yourself, can we divide 10 by 11 and not get a remainder? And the answer is no. 11 does not divide into 10 without a remainder, so we cannot divide 5,182 by 11 either. So let's try one more example with a larger number. Now you'll notice that for all of these divisibility tests, we're answering the question why. That is going to be important. You're going to be able, or you're going to have to be able to demonstrate that you know a reason for saying yes or no that a number can be divided by each of these other numbers. And that reason has to be something other than I divided the number by another number. You have to state a reason in terms of divisibility rules. So let's start with 2. Can we divide 3,885,840 by 2 without getting a remainder? And the answer is yes, because it's an even number. For 3, we have to add all the digits of our number together and see if that's divisible by 3. In this case, it is, because if we add all the digits of this number together, we get 36, and 3 does divide 36. We can divide 36 by 3 without a remainder, so we can divide this original number by 3 as well. The rule for 4 is to look at the last 2 digits of the number, which in this case is 40. Can we divide 40 by 4 without a remainder? The answer is yes. The rule for 5 is to look at the last digit of the number. It has to be a 0 or a 5. It's a 0. So yes, we can divide this number by 5 without a remainder because it ends in a 0. The rule for 6 is to look back at your rules for 2 and 3. If both 2 and 3 worked, if 2 and 3 both could divide into your number without a remainder, then 6 will as well. And in this case, we could divide by 2, we could divide by 3, so that means yes, we can divide this number by 6 without a remainder because it's divisible by both 2 and 3. 7. So the rule for 7 was cross out, double, subtract. So let's see. We start by crossing out the 0, doubling 0, we get 0. Subtract that 0 from the remaining number that we have, and we get a huge number, 388,584. I have no idea if we can divide that by 7, so I'll keep going with this process. Cross out 4, double 4 to get 8, and subtract. That's still too big. I can't tell if I can divide that by 7. So let's keep going. Cross out 0, double 0, and subtract. Still pretty big. I can't tell. Let's keep going. Cross out 5, double 5, and subtract. Still can't tell. Let's cross out 8, double 8, and subtract. Aha! Now I can see that I can divide 21 by 7 and not have a remainder, which means, yes, we can divide our original number by 7 as well. And the reason I'm going to give is that 7 divides into 21, and I have my supporting work for that shown with this process. The rule for 8 is to look at the number formed by the last 3 digits, which is 840. So can we divide 840 by 8 without a remainder? The answer is yes. The rule for 9 is add together all the digits in the number. If you can divide that number by 9, then the original number can be divided by 9. We've already added all these digits together and we found out that they were equal to 36. 9 does divide into 36 without a remainder, so yes, we can divide our original number by 9. For 10, we look at the last digit of the number, which is a 0. And since it's a 0, we can say yes, we can divide our number by 10. The rule for 11 we called the ocean waves rule. So here's why we called it the ocean waves rule. We're going to add together alternate digits. So we'll add together the 3, the 8, and the 0 to give us a 19. And then add together all the digits we didn't add. They also alternate. So that's the 8, the 5, and the 4. And they add to give us 17. So now you subtract those two numbers. 19 minus 17 is 2. So the question is, can you divide 2 by 11 and not get a remainder? And the answer is no. So we cannot divide this original number by 11 either. Our justification for that is going to be the work that we did showing the sums of the alternate digits, and then the difference of those two sums. Our 19 minus 17 is 2, and from that we can say, since 11 does not divide into 2, then 11 does not divide into our original number. So when it comes to working with these divisibility rules, you are going to have the rules memorized, and you're going to have to be able to apply them to numbers and state reasons for why a number is or is not divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And that reason has to be a reason grounded in the divisibility rules. It's not a reason that's grounded in actually doing a division.